The first and most important step is called capture. This is where we grab the carbon dioxide. Most of the time, this happens at big industrial sites like power plants that burn fossil fuels or factories that make things like steel and cement. There are three main ways scientists and engineers do this. The first method is called post-combustion capture. In this process, we let the factory burn its fuel as it normally would. Then, as the exhaust gases, the smoke, are about to go up the smokestack, we use special liquid chemicals called solvents to grab onto the CO2 molecules, separating them from everything else. It's like using a chemical sponge to soak up just the CO2. A second way to do this is called pre-combustion capture. This one is a bit different because it happens before the fuel is burned. With this method, we react the fossil fuel with steam and air or oxygen to turn it into a mixture of gases, mainly hydrogen and carbon dioxide. It is much easier to separate the concentrated CO2 from this gas mixture. Once the CO2 is removed, the remaining hydrogen gas can be burned to produce energy. And the best part is that when you burn hydrogen, the only thing that comes out is water. This is a very clean way to generate power, and we've already captured the carbon before it could cause any trouble. The third method is known as oxy-fuel combustion. This sounds complicated, but the idea is pretty simple. Instead of burning a fuel like coal in regular air, which is mostly nitrogen, we burn it in almost pure oxygen. When you do this, the exhaust gas is almost entirely made of water vapor and a very high concentration of CO2. Since there isn't much else in the mix, it's super easy to separate the CO2. We just have to cool down the exhaust to condense the water, and we're left with nearly pure CO2, ready to be transported. Each of these methods has its place, and engineers choose the best one depending on the type of factory or power plant. So, whether we're catching the CO2 after the burn, before the burn, or by changing the way we burn, the goal is the same: to isolate the carbon dioxide. This step is a critical part of the whole CCS process. It's like being a goalie for the planet, stopping the CO2 puck before it can score a goal in our atmosphere. This technology allows us to tackle emissions from sources that are difficult to decarbonize otherwise. It's a powerful tool in our toolbox for building a cleaner future for everyone. Science is pretty cool, isn't it?